Hi, my name is Anshuman Singh and I'm in my final year at Griffith University. I've received my diploma in aviation. Today, my group, Jace Icey, Bronte Tuxworth and Sarah Bryden, will be investigating the Cessna 206 behind me. The Cessna 206 is a heavier and faster option for commercial training and charter operations. It requires a bigger step up in skill level to fly. However, it is also the most commonly used aircraft in single-engine entry-level jobs in Australia. The Cessna 206 is used as a platform for those looking to achieve a commercial pilot license and a manual propeller pitch control or constant speed unit endorsement. Built to haul payload, the 206 features 6 seats, a powerful 300 horsepower Continental engine, average block true airspeed of 135 knots, and a well-equipped avionics package. The key light aircraft components and systems we will be covering today are the interior and air vents, the CSU system, fuel system, airframe and control features, hydraulic system, electrical and ignition systems, and the engine. The Cessna 206 uses a CSU propeller, constant speed unit propeller. This is it over here. It has 3 blades, 1, 2 and 3. The manufacturer of the propeller is the Macaulay Accessory Division. The most common arrangement found in modern aircraft employs a constant speed propeller, which automatically maintains a given RPM by responding to pitch change commands from a governor. The pilot sets the desired RPM value with the pitch control lever, and the governor automatically adjusts the blade angle to maintain those RPM at various speeds and power settings. A diagram of the governor system has been drawn behind me and I'll explain the different components. The disc bearing, the speeder spring, the 2 flyweights, 2 pivot points connected to the flyweights, the plunger stem, and the pilot valve. The fixed force are counterweights with spring or compressed gas. The centrifugal force pushes the flyweights out. If the propeller RPM begins to decrease, the speeder spring force becomes greater than the centrifugal force, pushing the pilot valve down. This shuts off the pressure line and opens the pathway for oil to return to the sump. This moves the blades towards a finer pitch, reducing the propeller torque and taking the brakes off, again returning the RPM to the original value. When the RPM is too high, the speeder spring force is lower than the centrifugal flyweight force. Therefore, the oil goes to the hub, and therefore decreases RPM by making pitch coarse. When the aircraft is on speed, the speeder spring equals the centrifugal force of the flyweight. Oil in makes blades go coarse, and oil out makes blades go fine. So over here what we have is the air vent system. So over here you can see air vents, 1, 2 and 2 on the other side of the wing. Basically, what the air vents do is they provide air for the passengers and the pilot inside the aircraft. The air vents outside are connected to the air outlet points inside the aircraft. There are 6 outlet points in the aircraft. There's one here, and to activate air, to allow air to come in for the passengers and the pilot, you open this up slightly like that, and that will allow air while flying into the aircraft. It even has an air vent on the side of the left engine cowl as well as the right engine cowl. The aircraft utilises another vent which is designed just for the battery. And finally the cowl flaps provide cooling for the engine.
Hello, my name is Yamato Issei. I am a 3rd year aviation student at Griffith. Engine ignition on the 206 is provided by 2 magnetos and spark plugs for redundancy. Magnetos are a self-contained and independent source of voltage for the spark plugs to enable the engine to continue to operate even after failure in the electrical system.
The right magneto fires the lower left and upper right spark plugs, and the left magneto fires the lower right and upper left spark plugs. Normal operation is conducted with both magnetos due to the more complete burning of the fuel-air mixture with dual ignition. Ignition and start operation is controlled by a rotary type switch located on the lower left of the control panel. The engine should be operated on both magnetos except for during magneto checks, as operating with only one magneto will yield decreased engine performance. The R and L positions are for checking and emergency use only. When the switch is rotated into the spring-loaded start position, with the master switch in the on position, the starter contactor is energized and the starter will crank the engine. When the switch is released, it will automatically return to the both position. The aircraft is equipped with a 28-volt direct current electrical system. The system uses a battery located on the upper left forward portion of the firewall as the source of electrical energy, and a belt-driven 60-amp alternator to maintain the battery's state of charge. Power is supplied to most general electrical and all avionics circuits through the primary bus bar and the avionics bus bar, which are interconnected by an avionics power switch. The primary bus bar is on any time the master switch is turned on, and is not affected by starter or external power usage. Both bus bars are on any time the master and avionics power switches are turned on. Electrical systems on board the 206 include pitot heat, propeller and windshield anti-ice systems, auxiliary fuel pumps, flaps, radio and transponder, avionics, navigation aid, engine starter motor, stall warning system, and lights inside and outside the aircraft. Each component is connected to an individual circuit breaker for protection from a current overload. The battery is responsible for driving the starter motor to start the engine, and is a backup electrical supply once the engine is running. The ammeter, located on the upper right portion of the instrument panel, indicates the amount of current in amperes from the alternator to the battery, or from the battery to the airplane electrical system. When the engine is operating and the master switch is turned on, the ammeter indicates the charging rate applied to the battery. In the event the alternator is not functioning or the electrical load exceeds the output of the alternator, the ammeter indicates the battery discharge rate.
Hi, I'm Bronte Tuxworth in my final year of my Bachelor of Aviation, and I'll be discussing the external features of the Cessna 206. The Cessna 206 is an all-metal, high-wing aircraft measuring 8.6 metres in length. Semi-monocoque structures use features like bulkheads, formers and stringers to carry the primary load, rather than relying on the strength of the skin. The main components of the Cessna 206's structure include the front and rear carry-through spars which support the wings, a bulkhead and forgings located behind the pilot seat to which the landing gear is attached, a bulkhead behind the instrument panel with plates to attach the base of the wing struts and structural engine mounts. The aircraft's wing design features a straight leading edge and tapered trailing edge. The high wing feature of the aircraft means the aircraft is generally less likely to naturally enter a spiral dive. As the cabin mass sits below the wing, the centre of gravity is low in relation to the centre of lift. In this configuration, the fuselage acts as a pendulum, encouraging the aircraft to level flight. This particular wing configuration also allows for unobstructed visibility around and below the aircraft, as well as greater ground clearance, resulting in debris protection. The Cessna 206 has large span single-slot flaps and frieze ailerons located in the trailing edge of the wing. The frieze ailerons are unique in that when the aileron is deflected up, the leading edge protrudes below the undersurface of the wing into the airflow beneath the wing. This is thought to help counteract adverse yaw. Cessna 206 has a conventional tail assembly with vertical and horizontal stabilizers. The vertical stabilizer is made up of forward and aft spar and formed sheet metal ribs, 4 skin panels, formed leading edge skins and a dorsal, and houses the rudder. The elevator control surfaces are housed in the horizontal stabilizer. The rudder and elevators provide the primary flight controls, which allow the pilot to control yaw and pitch respectively. Manual operated rudder and elevator trim are also provided on this aircraft, as well as downsprings on the elevator control system to improve stability in flight. These primary and secondary control surfaces are all operated manually through mechanical linkage. The Cessna 206's fuselage includes a door on the left side of the cabin at the pilot seat position and double cargo doors in the right side of the cabin at center and rear passenger seat positions. These cargo doors allowed access to the baggage compartment, which is the area behind the rear passenger seats, to the aft cabin bulkhead. Depending on seating configurations, this space can range from 90 centimeters to 240 centimeters in length. The Cessna 206 has fixed tricycle-type landing gear with a steerable nose wheel and 2 main wheels with fairings. The main landing gear has leaf spring steel struts, which provide shock absorption, as well as hydraulically operated disc-type brakes. These brakes are connected by hydraulic line to a master cylinder attached to the rudder pedals. Each wheel has its own separate braking system, allowing for differential braking.
Hi, my name is Sarah Bryden. I'm in my final year at Griffith University. I'll be talking about the fuel system and the engine system today. In the Cessna 206, there is a 4-stroke cylinder engine. The First stroke is induction, second stroke compression, third stroke power, and fourth stroke exhaust. The first stroke of the four-stroke engine is the induction, or the intake. In the induction stroke, the air comes in through here when the inlet valve opens, and the piston moves from the top dead center down to the bottom dead center. Now in the next stroke, compression, the piston moves from the bottom to the top, and the inlet valve closes, making sure that air and the fuel can compress. In the third stroke, the combustion stroke, otherwise known as the power stroke, the air is already compressed previously from the compression stroke. The spark plug ignites the fuel/air mixture, sending the piston down to bottom dead center, which in turn turns the crankshaft, which turns the propeller. Now in the final stroke, the exhaust stroke, the piston comes back up and exhausts all the air out from the valve, which opens, the exhaust valve that opens, and the inlet valve is closed, obviously. The Cessna 206 has two tanks, one in the left wing, one in the right wing. Both tanks have their own vent to ensure that when the fuel is drained out, the pressure is then equalized with air. The caps are vented also in case if these check valves become blocked. Each tank draws to its own fuel reserve tanks, which also has a drain valve to check for fuel quality. It is then drawn into the fuel selector, which is then drawn, and the fuel selector obviously chooses left or right tank. Once the tank is selected, it will then draw to pass the auxiliary fuel pump, which is used to prime the engine, and in case of engine failure, in the engine-driven fuel pump. It then moves from the auxiliary fuel pump down to the fuel strainer, through to the engine fuel pump, where it is pumped, and then into the fuel/air control unit. The fuel/air control unit does the mixture and throttle control, is connected to the mixture and throttle control, which then delivers the air to the fuel manifold. The fuel manifold then splits the fuel into the 6 different engines/cylinders. The fuel flow indicator is also connected in this stage of the fuel pressure. The fuel flow indicator is located in the right side of the cockpit for the pilot when he's flying. The fuel manifold evenly distributes the fuel to an air bleed type injector nozzle in the intake valve chamber of each cylinder. A turbine type fuel flow transducer mounted between the fuel/air control unit and the fuel distribution unit produces a digital signal that displays fuel flow. The Cessna 206 has 2 fuel tanks. They are located in each wing. There are 3 fuel drains located at the bottom of the engine. There are 5 fuel drains located underneath the wing. 1, 2, 3, 4, 5. Now there's another 5 on the other side of the wing. The Cessna 206 uses 2 types of fuel, the 100 low lead grade aviation fuel, which is blue, and the 100 grade aviation fuel, which is green. Now this aircraft is able to hold 92 gallons, which is 46 gallons per tank. However, 4 gallons of it is unusable, so only 8 is usable, and which is used for flight planning.